here we're going to look at a proof of the Pythagorean theorem. Now, there are many proofs of the Pythagorean theorem. Back in the Greeks' time when they knew it, they had a proof which shows up at the end of book 1 of Euclid's famous book, Elements, probably the most famous math book ever written. But here we're going to do a geometric proof. I think this was first done by the Chinese. I'm not sure how long ago. But we're going to do a geometric proof. And, well, we'll start with this square. It's a square. Not a rectangle, it's a square. And what we're going to do is mark off a point on that side. And we're going to label the two sides the two pieces of the top line A and B. So we have a point. We're going to call that A and B. And we're going to do the same thing on these other sides. We're going to try to make them the same size in our drawing. Well, they are the same size. Well, for our purposes, they will be the same size. A and B. A and B aren't the same size. We're dividing the line segment into two pieces, A and B. We're going to arrange them like this, so that at a corner, we have an A and a B meeting. So here I'm making A a little smaller than B. That point should be a little bigger. And here we have an A and a B. And what we're going to do, so where's the Pythagorean theorem come? The Pythagorean theorem, remember, says the sum of the legs of a right triangle. No, it doesn't. It says the sum of the squares of the legs of the right triangle equal the square of the hypotenuse. Well, I don't see any triangles yet. But what we can do is connect these dots like this. And that object in the middle is going to be a square because A and B are consistently labeled across the sides. So here, we'll call that hypotenuse C. And because A and B are the same for all those other things, all four of these sides are going to be C. So now, if we show there are four right triangles there. If we show for any one of those right triangles that A squared plus B squared equals C squared, well, there's the Pythagorean theorem. So let's do that. How are we going to do that? Well, notice, what's the area of the big square? Not the square with C's on the side, the squares with A's and B's on the sides. The area of the big square, the side length is A plus B. So the area of the big square is A plus B all squared. Now, one of these sides, this side, for example, that I'm shading in, that has length A plus B. So the area of the big square is that side squared, A plus B squared. And what is the area of those five objects in the middle? Well, let's start with the triangles. Notice we have four right triangles. The right triangles are all A, B, C. What is the area of a right triangle? Well, remember, the area of a right triangle is a half times, well, the area of a triangle is a half times base times height. The base for these right triangles, let's shade in this one, I guess. So for this triangle here, the base is A. The height is B. So the area of that triangle is a half times base times height, a half times AB. So one of those right triangles is a half AB. So four of them is 4 times a half AB. So right here on the left side of the equation, we have the area of the entire square. The right side of the equation, we have just the 4 rectangles so far. So that equals is not true yet. We have to add the area of the big square in the middle, the C's, the one with C's. The area of that big square in the middle is C squared because it's a square with side length C. And what do we get if we simplify this? Well, A plus B squared, remember, is A squared plus 2AB plus B squared. what's the left side? Sorry, what's the right side? Well, 4 and 1/2 make 2. So you have 2ab plus c squared, and then the two ab's cancel, and you subtract 2ab from both sides. And you get a squared plus b squared equals c squared. Sorry, that was a line that I accidentally drew. That shouldn't be there. So a squared plus b squared, let's put a QED at the end, because it has been shown. Quote error demonstrated. That's how you end proofs in math, if I didn't mention that this semester. So a squared plus b squared equals c squared. That last plus should be an equals. Sorry. That's a good way to end your proof with the wrong thing. A squared plus b squared is the left side. C squared is the right side. So a squared plus b squared equals c squared. So we showed that. That shows the Pythagorean theorem. Now, I'm not going to ask you to prove the Pythagorean theorem. This is just, I would imagine most of you have not seen a proof of it. And, last year in maybe February, one of the professors at Muhlenberg, Dr. McGuire, mentioned this proof, and I thought, oh, this is a cool proof of a nice result that most people probably haven't seen. So I did want you to see this.